Fred Sieber, Professor Emeritus from Camden County College. You're about to venture into the exciting world of photonics by taking Module 1 in the first course called Fundamentals of Lasers and Light. This module has a title called Nature and the Properties of Light. What are some of these properties? They are reflection, refraction, diffraction, interference, dispersion, polarization. Again, these are wave properties of light. A discussion of wavelength, frequency, and energy will also be made to make sure you understand how they relate to these other properties. We will also look at properties of laser light. I was talking about properties of waves before, but now how about properties of lasers? Properties of lasers will include coherence, a very important aspect of why lasers are what they are and what power they are able and energy they're able to develop, and that is the in-phase nature of laser light called coherence. A discussion will also be made of the electromagnetic spectrum, starting with radio waves that have very long wavelengths and low frequencies, going to gamma rays that have short wavelengths and high frequencies, and then spending time about in the middle in the visible spectrum, red, orange, yellow, green, blue, indigo, and violet, and their wavelengths are from about 700 nanometers approximately to 400 nanometers, or 7 times 10 to the negative 7th meters, down to 4 times 10 to the negative 7th meters, with frequencies about 10 to the 14th hertz. It's not only going to be a discussion of wave properties of light, properties of laser light, and the electromagnetic spectrum, but some of the other things that we will be talking about will be the duality nature of light. The duality nature of light. Is light a particle or is light a wave? And you know, there's a great deal of discussion at the time of Isaac Newton and his talk about corpuscles, and then obviously the work that Albert Einstein did later on, and Christian Huygens before him. But it was Thomas Young in 1801 who performed his famous experiment called Young's double-slit experiment, which sort of brought things together for Christian Huygens because it did demonstrate the wave nature of light by the properties of diffraction and interference. So yeah, guess what? We do have a duality when it comes to light. You can't explain lasers unless you talk about the photonic or the particle nature of light, and you can't talk about how light reacts in a lake or light reacts in glass unless you talk about refraction and reflection. In this module, there's also going to be a discussion of absorption and scattering of light, of black body radiation, and also there's going to be discussion of laser safety. Obviously, laser safety is very important. In the first module, you're not going to be working with powerful lasers. You'll be working with diode lasers, which I'll demonstrate in the laboratory section of this video, but you also might be working with a higher power laser pointers, as I'm using now. This is a different wavelength, obviously, than most laser pointers. This is green versus the red wavelengths. We always have to be careful about when you use a laser. You never want to look into the beam. You want to make sure that if people in the room, they are aware of that you're going to be using a laser. And just take some precautions on what we call Class 2 or Class 3A. The new version in ANSY's Class 3R, but your laser is probably going to be labeled with Class 3A. So laser safety becomes important. In the following module, you're going to have a much greater discussion of laser safety. You'll talk about signs, you'll talk about the ANSY classifications, you'll talk about hazard zones, you'll talk about control methods.